Okay, hello guys. Today I'll talk about what is the continuity of a function. Right, continuity of a function. For this, I've defined what are the limits. Okay, in the limits, I defined that what is the left limit, right limit, and the limit of the function given. If a function is capable of graphical presentation, okay, then if there is no break in the curve of the function given at any given point A, then the function is said to be continuous. Okay, and the point A is said to be point of continuity. If there is a sudden break in the curve of the function given at any given point, let me take x equal to A. Okay, at A point there is a sudden break in the given function, given curve of the function, then the function is not continuous, it is discontinuous, and the point A is said to be point of discontinuity. Okay, and so this is how graphical definition is there. I'll talk about what the mathematical definition or the arithmetical definition of the continuity that later I'll take, but let me first define what is the graphical presentation, or how graphically we can define what is the continuity of a function. So let me take one example that how a function, or let me define, if a function fx is capable of graphical representation, let me take graphical representation, then the curve of the given function, does not have any break at a given point. Let me take at a given point A, okay, at x equal to A, then the function is said to be continuous function, and the point A is said to be point of continuity. Okay, then the function is said to be a continuous function. And the point A is said to be point of continuity, and the point A is the point of continuity. Alright, and if there is a sudden break in the curve of the given function at a given point A, then the point A is said to be point of discontinuity. Let me take an example. Let fx equal to x square minus a square on x minus a. Here, at x equal to a, this function is not defined. If I represent this graphically, then what the graphical represent? Let me take here 0 is the x-axis, x dash axis, y-axis, y dash axis. Okay, this is coordinates geometry. Now in this case, let me take this is a point at x equal to a. This is a here, this is minus a here, at equal distance minus a, and let me take this is a. On the graph here, at x equal to a of this, okay, and at this point, this graph is not defined in this case. At x equal to a in this case, this graph is not defined because this is non-determinant form or undetermined form of the function given. If x equal to a, then 0 upon 0, so the function is not defined at x equal to a. Okay, so this function is not defined at x equal to a. This is point of discontinuity here. So at x equal to a, the function is not defined. So there is a break, sudden break here. Alright, so if I define it, this is a, y equal to a, or fx equal to, this is fx equal to, here it is fa, if I talk about fa. Okay. So fx equal to fa, in this case, at this point a, when x is 0, then we have fa equal to a, so this a point. But when x equal to x is approached from left limit of a, right limit of a, then the value will be 2a. So that 2a is, but 2a is not defined here. But if it is approached from left hand limit and right hand limit of a, so left means negative sign, positive sign, okay, or of a, x equal to, when x equal to a, and if it is defined from left hand side and right hand side, then the function is. And I'll just talk about that, how this function is not defined at this point x equal to a. In this case, this function is not defined x equal to a, right? So even if the left limit, right limit of this function exists, which is equal to 2a, here let me take left limit or right limit of this function. So if this graph, or I mean this given function is not defined at x equal to a, in this case, there is a certain break. This point of this a is known as point of discontinuity of this graph. And I'll just talk about how this function is made to be continuous, or if there are certain conditions given. So now let me first define what is mathematical definition of this graph. So point of discontinuity, point of continuity, if there is a certain break in this point. So in this case, for example, x equal to a is a point of discontinuity. Now when our function is now mathematical definition or arithmetical definition, mathematical definition of continuity given by Gauss continuity. Okay, so this is now arithmetical or mathematical definition of Gauss. If a function fx is continuous at every point a, at every point of an open interval. Let me take open interval of an open interval let me take, this is open interval I, and at a given point a, or at every point of this open interval, given point a, or at every point of this given interval, of this open interval I, right? And fx equal to fa exists, right? Then the function is said to be continuous. The function is continuous if the following exists. First of all, limit extend to a, fx equal to fa exists. Value of the function exists. Okay, second point, this is the first one. Limit extend to a, fx exists. Okay, and its value is this fa at given point a, and function fx exists at the given point. And secondly, we find epsilon any smaller number, okay, whatsoever, then value of the function fx minus fa is less than epsilon, however small, and corresponding we find a delta and the number delta which is positive less than 0, and delta, let me take it, greater than 0, then x minus a is less than delta. Okay, for every positive number. So here a is any point in the interval of this is a minus delta, a plus delta. So in the left side of a, right side of a, value of the function exists, or the value is equal. Okay, in the open interval this, if we are able to find out any smaller number, difference of this function exists which is less than this one. Okay, and difference of this number a and of the value of the function at x equal to a also exists at which is a smaller number, then we say that the function is continuous at given point a. Okay, so let me take this geometrically how we have to represent this definition of continuity graphically. Okay, if there is any point epsilon and what is delta, let me define them. If I represent them graphically, okay, let me take this. This is x dash x is 0, y and y dash x. This is the origin. Okay, and if I just talk about that there are, this is value of the function fx, okay, plus f, or let me take epsilon, I'm sorry, this is fx plus not a, but this is epsilon, okay, and here it is fa, fx equal to fa, here it is fa at point a, and less than this is a minus, I'm sorry, this is fa minus epsilon, this is fa, sorry, fa plus epsilon, fa minus epsilon. Okay, and the graph is like this. This is at a, and the graph like this is here. Value of the function. Okay, and this is the point here, and the point is, let me take here. This is the point, and next point is this. This is let x equal to a here, and this is x minus, sorry, a minus delta, and this is a plus delta. So at a plus delta, a minus delta, and x equal to a, the value is fa minus epsilon at a minus delta. At this point this is this value, and the graph is continuous. There is no break. Okay, at x equal to a, the function is continuous. In this case, we can just talk about this fa plus epsilon. This is fx equal to fa. At this point, fx equal to fa. Value of the function exists here at x equal to a. The function is continuous graphically. We can represent this continuity of the function like this as well. And if I draw a graph like this, in this case the function is not continuous at x equal to a. Now let me take some example. Okay, and let me define that what is left limit, right limit if they are equal, and they are equal to the value of the function at the given point a, left limit, right limit, and the value of the function at the given point a, and all the three are equal, then the function, we say that is continuous in the open interval of the given function, right, or given interval. So let me take, if there is a function, so if a function is continuous, if a function is continuous, in the open interval, let me take open interval, it is either we represent AB like this, or this is open interval AB. We represent open interval like this. This was the yes, closed interval, opposite of closed interval, of open interval. Okay. Then at every point of this, so if a function is continuous, it continues in the open interval or in this interval. At every point of it, at every point of the given interval, the given open interval, then the function is continuous. The function is continuous. If either both left limit or right limit, if either both, let me take here, left limit or right limit, or either both left limit or right limit, or either of them, or either of them, let me take, does not exist, or equal to the value of the function, function at a given point, in that interval, in the open interval, in that interval, then the function is discontinuous. Then the function is discontinuous. I defined that what is the left limit, right limit in the case of limits. Okay, so if all the three limits, for example, if limit x tend to a from left limit, fx is equal to limit x tend to a from right, fx equal to the limit of the function as x equal to a, fx equal to fa. In this case, function is continuous, right? There is no any break, or all the three limits are equal, left limit, right limit, and the value of the function at that point. So this function is continuous. In this case, function is continuous. Function is said to be continuous. Continuous function, right? Vice versa. If either of them is not equal, or it does not exist, left limit is not equal to right limit, and okay is not equal to right limit, but equal to the value of the function, even then, so all these three must be equal in case of function is continuous. Okay. In this case, for example, in this question, the function is not continuous at x equal to a. Now let me define in either way. In another way, the function is continuous. If the value of the function is, in this case, the function is not continuous at x equal to a, here fx equal to x square minus a square upon x minus a. It was this, the limit x tend to a. In this case, function is not continuous because this 0.0 form, x tend to a, then value is 0.0. Function is not defined at x equal to a, so function is not continuous. But if I define fx in this way, that this is x square minus a square upon x minus a when x is not equal to a. That means left limit and right limit are equal to this, and equal to 2a when x equal to a. Right? In that case, when x equal to a, then value is 2a. So we have not to apply this. The value directly will be x equal to a, 2a. In that case, the function will be defined. Okay, so in this case, let me take the left limit, and extend to a plus, or let me take a minus. That means the left limit for fx equal to this value. Limit extend to, we take a plus h, where h tends to 0. Here h tends to 0. If I replace x by a plus h, and where h tends to 0, then fx will be equal to limit h tends to 0. So if I replace this function, this is a plus h whole square minus a square upon a plus h minus a cancel out. This will be equal to, when h tends to 0, let me open this, limit h tends to 0, it will be a square plus h square plus 2ah minus a square divided by h, only a square cancel out, and divided by h, so we will get only 2a. So this is equal to 2a. In that case, left limit equal to 2a. Right limit will also be 2. Sorry, this is left limit I have taken, this is minus a, I'm sorry, and this is minus 2a. Okay, so a minus h. A minus h, if I keep it here, a minus h, or h tends to 0. Okay, so then it can be, the value will be equal to this one, h tends to 0. Or if I just factorize this method, so this is a minus 2h. If h's cancel out, so this will be minus 2a. In that case, why it's minus 2a? Sorry, a plus h, and in the denominator we are having a minus h, so minus cancel out, so it will be plus then. In that case, it is minus h, sorry, it is minus h, left limit. So a minus h we have to substitute, so the value will be negative positive, so 2a. Left limit is 2a, right limit will also be 2a. Extend to a plus to fx is equal to, again h tends to 0, a plus, that means limit x tends to a plus h, where h tends to 0. Right, so this is equal to, I'm sorry, this is fx equal to limit h tends to 0, and this is a plus h whole square minus a square divided by a plus h minus a cancelled out, and in the denominator also we will have the same thing, a square plus h square plus 2h and minus a square cancelled out, so 2a only positive. Left limit equal to right limit, left limit equal to right limit, and equal to the value of the function. Value of the function is 2a, we are given that x equal to a, value is 2a. Okay, and the limit x tend to a, fx equal to 2a, which is given to us. So all the three equal. In this case, function is continuous. So the function which is not continuous, now given values or whatever given interval, it can be made continuous in this way. So we have defined this function in different way, then the function is continuous. Continuity and discontinuity of the function is very simple. We have to prove that left limit, right limit, and the value of the function at the given point all are equal. Then the function is said to be continuous. Okay, so this is mathematical definition. Graphically, if there is any break, function is discontinuous. There is no break in the curve of it, function graphically represented, then the function is continuous. So no break, continuous function. If there is a break at given point, then the function is discontinuous at that given point. Okay, so let me take some more examples. Now, define whether this function fx equal to x, this is second question now. Define is continuous or discontinuous at x equal to 0. Correct, at x equal to 0, left limit, right limit, what are the left limit, right limit? Is function continuous or discontinuous? Let me solve it. So limit x tend to 0 from left. Okay, so before that, this is fx equal to limit x tend to 0. Let me take minus h. 0 minus h, where h tends to 0. 0 minus h or 0. This is negative point, so minus x upon x only. This is minus 1. Okay, so minus 1. Before that, if I find out the absolute value of x, then in case of negative less than 0 value, it will be negative sign, it will be minus 1. In case of right limit, limit x tend to 0 positive or 0 from right, so this is right limit. In that case also limit x tend to 0 plus h, or where h tend to 0. So again, this is positive x divided by x. The modulus x will be x, so this is equal to positive 1. Positive 1. In that case, the value will be, plus x upon x, that means positive 1. So these left limit, right limit are not equal. Function is discontinuous. So we say that function is, here fx is discontinuous. Is discontinuous at x equal to 0. Okay, so how function is continuous, discontinuous in this way? Let me take some more questions which are mostly asked by the students. Okay, so let me take one more example and more example. Check whether this function modulus x minus 1, or absolute value of this modulus of x minus 2 is continuous or not continuous, is continuous or not at x equal to 2. Right? So at x equal to 2, is this function continuous or not continuous? So what are the absolute values of function when value of the function in the neighborhood of 2, that means left side or right side of 2. Let me take left limit, right limit of this. Limit x tend to 2 from left, that means 2 minus h, or less value. It will be modulus x will be then, let me first write them, x minus 1 plus it is x minus 2. These values will be limit x tend to negative, it will be positive 1. So less than 2 means this minus value is present of it. This value will be positive, x minus 1. It will be, because it is less than 1, less than 2, so it will be negative, minus x plus 2. So what do we have? This is equal to 3x, sorry, x, so x plus 1. And if I put x equal to 2, right, x equal to 2, that means 3 only. So value will be 3. X tend to 2 minus h. So it will be, when h tends to 0, 2 minus h. So 2 minus h at 0, 2 plus 1 is 3. Okay. So if I, so this is 3, x plus 1, that means 3. When x equal to, we have applied x equal to 2 minus h, h tends to 0. So 2 minus h means 2 plus 1, 3. Alright, this is left limit. What is right limit? X tends to 2 plus. Then in case of plus 2, it will be positive. It will be x. We first write all them, x minus 1. So this is x minus 2. So these values will be x plus x minus 1 plus x minus 3, x minus 2. It will be 3x minus 3. When x equal to 2 plus h, or h tends to 0, then 3 to the 6, 3. It will be 3 again. 2 plus h means h tends to 0, so 2 plus h, 3 to the 6 minus 3, 3. Left limit equal to right, and what are the actual value of this? If I substitute x equal to 2 with 0, 2 minus 1, 1, this is 2. And at x equal to limit x tend to 2 only, so fx will be, in that case, this function will be limit x tend to 2, this is x plus x minus 1 plus 2 minus 2 0, this is 0, or x minus 2, right here, this is 3x minus 2, 2 again, 3 1, this is 3, 3 to 6, x tend to 2. So all the three limits are equal, so function is continuous. So this function is continuous. This function is continuous. Function fx. Its fx is continuous. Okay, so this is how we can define this. Now let me take one more example. If that function is continuous or not continuous. One more question. Let fx equal to x square when x is not equal to 1. Equal to 1. Let me take it is 2. Sorry. It is 2 at x equal to 1. Okay, so when it is left limit extend to 1 from left or not equal to means, that means left limit and right limit both are x square. This is fx. In that case, this is left limit extend to 1 minus h, where h tends to 0. This is 1 minus h whole square, and that means 1 only, because h tends to 0. All the terms which will contain h will be 0, only 1 will be there, so 1. Similarly, right limit left extend to 1 plus fx. This is equal to left limit, the limit extend to 1 plus h, where h tends to 0. So again 1 plus h whole square. That is also equal to 1, because the terms which will contain h, the two terms will contain h, they will be 0, and when h tends to 0, only 1 will be left over. So left limit equal to right limit. And the value of the function is 2. X tends to 1 only, well, at x equal to 1, fx, this is equal to 2. Right, so this value, all the three are not equal. So we say that left limit x tends to 1, this is left limit fx equal to right limit x tends to 1 plus fx, but is not equal to fx limit x tends to 1. So in this case, function is